Hello everyone, welcome to Raos Academy. Today again with new topic, I am here. Today we are going to discuss heat budget and pressure belts. Very important in climatology topic. Geography. Most of the students they get confused in this heat budget related topic or pressure, temperature related topics. Today we are going to discuss all these topics related to pressure belts, pressure variation, climatology. In climatology, this is very important topic. So, let us start the session with some PYQs. See, which one of the following gases is most abundant in the Earth's atmosphere. Earth's atmosphere. They are asking about Earth's atmosphere. A. Oxygen, B. Nitrogen, C. Carbon dioxide, D. Argon. See, very simple question they have asked in 2012. They have asked this question in 2012. Very simple question. Answer is nitrogen. First nitrogen, next oxygen. Next question. Second question. Which gas is mainly responsible for absorbing ultraviolet radiation? A. Oxygen, B. Carbon dioxide, C. Ozone, D. Nitrogen. Very simple, UV radiation, ozone layer, answer is C, ozone. Next, 2016 question, consider the following statements about the atmosphere. 1. Temperature decreases in troposphere. 2. Temperature increases in stratosphere. Temperature decreases in mesosphere. They are asking about temperature difference, which are correct. A. 1 and 2. B 1 and 3, C 2 and 3, D 1, 2 and 3. Very important, see whenever you are analyzing any PYQ, that much simple questions they are not asking nowadays. After 2020, question paper pattern changed, trend analysis changed. Now they are asking statement 1, statement 2 types. And whether statement 2 explains statement 1 or not. But you can learn themes from after analyzing UPS previous year questions. You have to take out some important themes from that PYQs and you have to read everything about it. Before question we have seen the ultraviolet radiation regarding absorbing ozone. Now they can ask about polar stratospheric clouds related to ozone, ozone depletion. Means everything about ozone you have to learn, everything about carbon dioxide means each and every option you have to analyze, like everything about oxygen, everything about carbon dioxide, ozone, nitrogen cycle also you can relate. Like if you analyze each and every option from your PYQs, most of the syllabus is covered from your PYQ analysis only. Like that you have to analyze each and every option, not the question. Question is important. And the theme, see questions may not repeat but themes repeats. So you have to observe even options also. Temperature decrease in troposphere, yes, true. Normal lapse rate. What we observe in troposphere? Normal lapse rate around 6.5 degrees per 1 kilometer. Around 6.5 degrees temperature is decreased as you go up. So statement 1 is correct. Temperature increases in stratosphere, yes, temperature increases. Negative lapse rate we have seen, negative lapse rate. Next, temperature decreases in mesosphere, yes, temperature decreases in mesosphere. All three are correct. Now what you have to learn, why temperature increases here? UV rays absorption, yes. See in 2014 they have asked about UV radiation, yes, related to ozone. Now they have asked about layers, tropo, strato and meso. Why ozone or UV radiation is related to tropostrato temperature in stratosphere? Because of UV radiation absorption you will see temperature increase as you go up, With altitude, temperature increases. Yes, all three, 1, 2 and 3 are correct. Next, why do jet aircraft prefer to fly in the lower stratosphere? They are asking about reasons. UPSC never asks where the jet streams fly, in which layer, but most of the times they will ask why, how. Less turbulence, stable temperature, absence of clouds. Answer is absence of clouds also. 1, 2 and 3. Next, the layer of atmosphere where gases are uniformly mixed is uniformly mixed. We have seen 2 layers. Uniformly mixed layer is homosphere. In heterosphere, layered gases based on their weight, based on their mass, we will see layers of the gases. Stratified. By uniformly mixed, you will see in homosphere. Homosphere. Which layers are covered in homosphere? Tropo, strato and meso, means around 0 to 90 kilometers. This from 90 to till exosphere. Hetero, thermo and exosphere is part of heterosphere. Next, statement 1, 2024 question. Thickness of the troposphere at the equator is much greater as compared to poles. Statement 2, at the equator heat is transported to great heights by strong convectional currents. They are asking about troposphere and strong convection and difference between the troposphere layer at equator and poles. We have seen in earlier sessions. Which one of the following is correct in respect of the above statements? Both statement 1 and statement 2 are correct. Statement 2 explains statement 1. Both statement 1 and 2 are correct, but statement 2 does not explain statement 1. See, statement 1 is correct, but statement 2 is incorrect. D, statement 1 is incorrect, but statement 2 is correct. In this question, yes, both statement 1 and 2 are correct, and even statement 2 explains statement 1 because of the strong convectional currents, high evaporation, air rises, low pressure, you will see strong convectional currents. Because of this strong convectional currents, thickness of troposphere at the equator is much greater as compared to poles. You don't see strong convection at poles. Low air sinks. Next, heat budget. Now we are going to learn heat budget. What is heat budget? Heat budget is a balance between incoming solar radiation and outgoing earth radiation. Budget refers to the balance between incoming solar radiation, insolation and outgoing terrestrial radiation. Outgoing terrestrial radiation which maintains the average temperature of the earth. If continuously earth absorbs solar radiation, if it does not emit any radiation back, continuously earth is heated up, right? So, to maintain that balance, we are going to learn heat budget. How? First source, sun. Sun emits short wave radiation. Short wave radiation and measured in calories or watts, distributed unevenly due to latitude. We have seen latitude because of equator. At equator mostly you will see vertical rays. Because of that vertical rays you will see more solar radiation. And as you go up from equator, the insolation decreases, and based on the season also. In summers you will see more solar radiation compared to winter seasons. And angle of incidence, because of the tilted axis we have seen variation. And length of the day, if length of the day is more than night, you will see more solar radiation, more incoming solar radiation is observed. Now, sorry. Electromagnetic radiation, these are the high frequency and high energy radiations. Short wave, and this IR radiation is emitted by Earth. IR radiation is emitted by Earth. Wavelength increases as you move here, wavelength increases. Major component of outgoing terrestrial radiation is infrared radiation. Major component of incoming solar radiation is UV radiation, ultraviolet. Even you have X-rays and gamma rays also, but major component is UV radiation. Outgoing long wave terrestrial radiation, IR radiation, that you have to remember. Incoming solar radiation, short wave. Incoming short, this is sun, this is earth. Short wave, here long wave. Outgoing terrestrial radiation, short wave short wave incoming solar radiation, mostly UV. Here mostly major component is IR, infrared radiation. Carbon dioxide or greenhouse gases, what they will absorb? They will absorb infrared radiation. UV absorption, stratosphere, ozone. UV is short wavelength, it is incoming solar radiation or outgoing terrestrial radiation. It is an incoming solar radiation. Next, when you see this diagram here, first we are going to talk about short wave solar radiation now. 100 units of solar radiation, they are coming. Here this is atmosphere. Listen carefully. This is atmosphere. This is Earth's surface. This is Earth surface. Here space. Now 100 units when they enter the space and into the atmosphere, here 27 units, they are reflected back by clouds. 27 units means these 27 units, they did not reach the surface, they have reflected back by clouds. Next, 2 units. 2 units, they are reflected back by earth, means still they did not touch the surface. From Albedo effect, because of that snow covered eye, means they are not absorbed. They are not absorbed. As soon as they fall, they are reflected back because of the albedo effect. Albedo effect. 2 units by earth. Clear? And next, six units scattered to space. Scattered to space. Total how many units reflected back and scattered? Total 35 units. Total 35 units. Out of 100, 35 units they are reflected and scattered back to the space. From, means they are not absorbed by earth's surface. 27 units from clouds, 2 units because of albedo effect and 6 units because of scattering into the space. Means these 35 units are not absorbed by earth's surface. Clear? Now 100 minus 35. Total 65 units are there. Total 65. Still 65 units are there. Out of this 65 units, how earth maintains, we are going to see. From these 65 units, 14 units are absorbed by atmosphere. Fourteen units are absorbed by atmosphere. Now out of this 65, 14, how many? 51 units they are absorbed by earth's surface. 51 units. This 14 units you have to remember, 14 units are absorbed by atmosphere out of 65, and from that 65 units if we deduct 14, 51 units are absorbed by earth's surface in the form of direct radiation 34 units and scattered radiation 17. Don't get confused here, again direct radiation 51 units absorbed by earth's surface, 34 units by direct radiation and 17 units by scattered radiation. If you calculate, again you will get 51 units, means total 51 units are absorbed by earth's surface, 14 units by atmosphere. This you have to remember. Now again, how much radiation it has to release? It has to maintain that budget, right? Now incoming solar radiation, clear? Next we are going to see the outgoing solar radiation. Here, outgoing terrestrial radiation, outgoing terrestrial radiation, that is long wave radiation. Here, again this is atmosphere, space, earth surface, you have to remember. Now radiation from earth 23 units. Out of this 23 units directly radiated to space, 17 units are directly radiated to space. Next, 9 units because of turbulence and convection are radiated back into atmosphere. Out of this 23, 17 were gone to space and 6 units are scattered into atmosphere. Now these 6 units, these 9 units, and because of the condensation, earth 19 units it radiated long wave because of the condensation, latent heat release during cloud formation. these 19 units. This you have to remember, 6, 9, 19 in atmosphere. 23, 9, 19, total 51 units are radiated back by Earth's surface. But these 51 units, out of these 51 units, only 17 units are directly gone to space. But here 6 units, 9 units and these 19 units are in atmosphere. Now these units, 34 units, 6 plus 9 plus 19, 34 units. These 34 units plus, that time we have seen 14 units, absorption of 14 units. How many units? 51 units. Means total 51 units Earth is absorbing and Earth is emitting incoming solar radiation. Clear? Emitted by Earth's surface. These 51 units are emitted by Earth's surface and atmosphere back into space. This is how we maintain equilibrium. Earth and Sun maintains equilibrium. Some heat escapes directly to the space and some is absorbed and re-radiated by greenhouse gases. Now, latitudinal heat budget. When you see latitudinal heat budget, here you will see more insulation at tropics. Here poles, you don't see that much heat, incoming solar radiation. Here at poles you will see energy deficit. Here incoming solar radiation is more. How this excess is transferred to deficit places? Through or via atmospheric circulation and ocean currents. These ocean currents, they distribute that heat, incoming solar radiation and even atmospheric circulation also. Warm wind, cold wind, all these carry, means they distribute that heat energy. If that distribution is not there, you will see continuously, means poles will be continuously frozen. You cannot survive there and you will see continuous more heat at tropics. So heat budget or this heat surplus and heat deficit, that heat redistribution is very important. Now at equatorial region, heat surplus you will see. At polar regions, heat deficit you will see. And to maintain this balance, atmospheric circulation and ocean currents, they transfer from equatorial region to polar deficit areas. Because of this, based on this, you will see global air circulation and ocean circulation. Now, distribution of temperature refers to the spatial. Spatial means horizontal, from this place to this place. Vertical, height. Vertical, we know already, we have seen lab state, normal lab state and negative lab state. Horizontal distribution we are going to see. Variation of temperature from place to place on Earth's surface is represented by isotherms. What are isotherms? Isotherms lines joining places having equal temperatures, For example, now here place A, here place B, here 10 degrees, if you have seen, here also 10 degrees. Means these two places are joined by a line or imaginary line. That line is known as isotherm. And again here C, here D. Here 20 degrees is there, here 20 degrees is there. If you join these two places, means through isotherms we can know the spatial distribution of temperature, where we are going to see the similar temperatures. So all this we can find through isotherms. Isotherms, January isotherms and June January and July isotherms are very important because at that time you will see summer and winter times. Means almost summer ending. Major temperature difference you will see. Now January isotherms shift southward, northern hemisphere. In northern hemisphere what you will see? Winter. In northern hemisphere you will see winter in January. Intense continental cooling. When you see continents, land cools very fast. So in January you will see intense continental cooling and isotherms bend equatorward over like this. Means all this 0 degrees you will see in the land and again in the ocean and again in the land. Southward shift. Remain smoother over oceans. Wherever you take in July or January, isotherms are smoother over oceans because oceans they don't get heated fast or means it takes time and temperature is also uniformly distributed over oceans. Strong land sea contrast we see in January and closely spaced isotherms in mid latitudes. Thermal equator south of geographical equator. Thermal equator or ITCZ zone we see this thermal equator based on the temperature difference, based on the incoming solar radiation, based on the equinox or solstice. This thermal equator shifts north or south based on the temperature. Here why it shifts south? Because in southern hemisphere you will see summer. More temperature is towards south. So thermal equator is shifted towards south. This you have to remember, very important. South of geographical equator. South of geographical equator. Currents warm poleward bend, cold equatorward bending we will see. Next. July shift northwards and reason intense continental heating. Because of intense continental heating you will see northward and isotherms bulge poleward over land, bend equatorward over oceans. Next, highest temperature in subtropical desert. If I ask during July isotherms highest temperature, where you will find highest temperature at equator? No, highest temperature, high insolation at subtropical deserts because you will see clear skies, because of that reflection is less by clouds. At equators you will see more reflection by clouds. Highest temperatures in subtropical deserts. Oceans show uniform temperature. Thermal equator north of our geographical equator. Why? Because during July what you will see? Northern hemisphere summer, more incoming solar radiation. Because of that this thermal equator moves. So in July shift is northward and in Jan shift is southward. This you have to remember. And transitional isotherms March, April and October during equinoxes time, near equator equinox time pattern nearly east to west. Minimum land sea because of this land sea contrast only we are going to see that southward and northward bending during January and July months. Here moderate temperature gradients, gradient means difference. Gradient means difference. Seasonal reverse in progress. Next, January dominant process cooling. January you can easily remember because it is winter. July heating. Land sea contrast very high. Here also very high. Isotherms bend over land towards equator. Here towards pole. Thermal equator south, here north. Means remember northern hemisphere. January winter means cool. Thermal equator comes down. Here summer in northern hemisphere. Thermal equator northward shift. Northward shift we are going to see. Next, adiabatic lap state is a rate at which temperature of an air parcel changes when it moves vertically in the atmosphere. Adiabatic lap state is very important. See, this is an air parcel. What is air parcel, ma'am? Air parcel, it has a uniform humidity, uniform pressure you will see, and it does not exchange heat with its surroundings. Everything, all the temperature changes are occurred inside that air parcel. It moves and inside that air parcel only you will see. No heat gain or loss, everything inside. Temperature change occurs only due to expansion and compression. Expansion and compression. See, air parcel is a small volume of air having uniform temperature, uniform pressure and uniform humidity. Now, how temperature changes without heat exchange? In conduction, convection we have seen heat exchange, but in adiabatic lapse rate, see, adiabatic lapse rate is nothing but normal lapse rate only, but here the temperature change occurs inside a air parcel. Means temperature decreases in this air parcel around here also 6.5 degrees. Rising air, when air parcel is rising from the surface, atmospheric pressure decreases. Same temperature and atmospheric pressure decreases as you go up. Atmospheric pressure decreases as you move up. These two decreases with height. Parcel pressure. Okay. Parcel pressure is more than surrounding pressure. Means you will see difference in the air parcel and surrounding pressure. Parcel expands. See, as you go up, here atmospheric pressure decreases, but here in this air parcel, compared to this atmospheric pressure, air parcel is having more pressure. Compared to atmospheric pressure, air parcel is having more pressure compared to atmospheric pressure. Means because of this pressure, air parcel expands, and expansion requires energy, and because of this expansion, whenever air parcel expands, it requires energy. So, energy is taken internally from air parcel's internal energy. Temperature falls, cooling is due to work done surrounding pressure. For this expansion, energy is taken, and because of this energy is taken from internally, temperature is decreased inside in this air parcel only. You don't see any loss or gain of heat from the surroundings, only everything in this parcel. Now this is expanding. For this expansion it requires energy. Internally this energy is taken by this air parcel. After taking this energy, temperature decreases as it move up. Temperature decreases means adiabatic lapse rate around 6.5 degrees temperature is decreased as this air parcel is moving upwards. Next, descending air. Now air parcel is coming down, descending. A pressure increases downwards. Now pressure is increasing. Parcel is compressed. Here there pressure is decreasing, air parcel is expanding. Here pressure is increasing. See, whenever I put any pressure, it compresses, right? It does not expand. Pressure means it compresses. Because of that compression, parcel is compressed. Compression adds energy and temperature rises. Simple, what you have to remember, when air parcel move upwards because of the expansion, air parcel expansion, you will see temperature decrease as it move from the surface. When this air parcel descends, come down, because of the compression, pressure, because of high pressure, you will see compression. Because of this compression, what you will see, temperature rises. Now, inversion of temperature. Inversion of temperature. Temperature increase with altitude. Normal condition, surface you will see warm air and upper layers you will see cool air. But in inversion of temperature, what happens here? Down you will see cool air and above you will see warm air. And this cool air acts like a blanket. This phenomena you will see in Delhi pollution topic. What happens? Clear skies. Calm and light winds, long winter nights. Because of this clear skies, all these we are going to see in winter season. That's why you will see more pollution during winter season in Delhi. Because of this what happens here? Why clear skies? See, if sky is surrounded by clouds, what happens? Radiation is re-emitted and these act like a blanket. If clear skies are there, radiation is, Earth's radiation is reflected into the space. And what happens here? Now this warm air is moving upwards. Here warm air is re-emitted if clouds are there. Here clouds are not there. What happens? This warm air moves up here in this void, in this vacuum place, dense cold air comes here at near surface. Next thing, calm or light winds. Why calm and light winds? Because it prevents mixing. It prevents mixing and you will see here cold air and above hot air. If strong winds are there, these two are mixed. Vertical mixing happens. This calm and light winds, what it prevents? Mixing. You will see stable stratification. And long winter nights, when you see long winter nights, longer duration of radiational cooling. More than heating, you will see cooling. Cooling means at earth's surface you will see more cooler air. Now cool air is dense. All the pollutants, they are formed like a lid in that cool air, dense air. This is inversion of temperature, smog formation you will see. Next, in mountain valleys, in hills and mountains, what happens here? Cold air drains into valley at night. From here, heat in the form of long wave radiation escapes into the space. When clear skies, long winter nights, all these conditions are unfavorable, what happens in hills and mountains? Cold air, they drain into the valley, and from here warm air is moved up, and here you will see air drainage. Air drainage means heavy and dense cold air acts like a water and move down into the valley. Whenever you see settlements on the hill, you will see settlements on the slope, because slopes you don't see that much heating or cooling on the slopes, but when you don't find any settlements in the valley, because at night times you will see air drainage, very cold air, presence of very cold air, temperature inversion you will see in the valley regions. Now, we have discussed about temperature, heat budget, and after that inversion of temperature, and even isotherms also. Next we are going to start about pressure, atmospheric circulation, and in that atmospheric circulation we are going to learn about pressure, pressure gradients and pressure belts. Atmospheric circulation. Okay. Atmospheric circulation, in next session we are going to see atmospheric circulation, fresh start. We are going to start with atmospheric circulation tomorrow in next session. Thank you. So, for your prelims, definitely you have to learn climatology, geomorphology, oceanography, all these are very, very important. In climatology also, they confuse with temperature difference. Next, pressure belts. Pressure belts you have to remember where is low pressure, where is high pressure. Next session we are going to learn, and please practice PYQs. PYQ analysis is very important, and daily practice MCQs. See, without practicing, just if you read, if you read all the topics, you don't remember. Practice is more important. Practice, read, practice and revise. Continuously you have to read and then you have to practice. You have to check whether I am going to means whether whatever I read I am able to put that knowledge on the paper, or I am able to analyze that question or not. That analysis is very important. So practice is very important, and after practicing any test, please do analyze your mock test also. Marks are not important. First you have to analyze. For example, if you have given 10 questions, out of that 10 questions, how many questions with perfect knowledge, after seeing that question, okay, I know this question very well. How many questions like that? How many questions are there? For example, 5 questions are there. And how many questions are in the 50-50 means guess, and how many questions are pure guess? Why this 50-50 confusion? Whether you are having lack of revision, or whether you did not read that topic, or based on just like that you have given that answer. That analysis is very important. If you see that 50-50% questions are more, means you are lacking in the revision part. If you are attempting 10 questions, out of that 10 questions, 6 to 7 questions you are able to give with good knowledge, without any confusion, then your preparation is on track. If more confusion questions are there, means you are simply reading, you are not revising the topics. Lack of revision creates confusion. Lack of revision creates confusion. Don't read many sources, read less sources, and with that less sources you revise, you practice, revise, revise. That strategy is very important for your prelims. Follow this strategy, and all the important topics, all the important themes, revise, practice, revise, very important. And don't forget your CSAT also. CSAT is very important. I have seen many aspirants who are very good at GS. Because of that CSAT fear, they are not able to clear prelims. They are very good at answer writing also, but because of that CSAT fear, they are not able to write mains. So be clear with your strategy. Don't get panic. Drink well. Almost summer. Drink well. Be hydrated. Prepare well. Thank you.